And folks, we're live here with this week's live stream from Trelis. Let me know if there's any issue with the sound and we'll get started. So a few things I want to cover today, and I've got a new layout here showing my face up the top right. I want to touch on the end of sequence token from the Llama 3 model, just talk a bit about loading that model. I'll also try and load the Phi 3 model, which just came out this week from Microsoft. It seems that the small Phi models are increasing in size all the time. Phi 1.5, I think, was about 1.5 billion parameters. Then the next one, Phi 2, was 2.7 billion. And Phi 3, the mini one, I think is over 3 billion parameters, maybe even 4 billion. So we'll take a quick look at that. Let me just get oriented here. I'm coming back from the gym. Hi, Loic. I see a question there on ORPO fine-tuning. You probably saw the video I made. In fact, you may have commented on it, using ORPO to do preference fine-tuning at the same time as supervised fine-tuning. I'm pretty sure it's the best way to fine-tune a model if you have preference data set. If anyone else wants to drop a comment here in the chat, let me know. I'll add it and I can show the comments just like this here, like Loic has. So to get things started, let's just take a look at that end sequence token on Llama 3. If you're live on the stream or afterwards, you can take a look at this collab notebook where I'll be working through the examples. So I'm just going to copy that link and I'll paste it into the chat here. So you can check out this notebook. I've made it publicly available. So we'll get started here with Llama 3. Hugging face. And my goal is to load the model and just do a simple chat and show you how basically in the Llama 3 model, the end of sequence token is not the stop token. And this results in the model blabbing on. Actually, it's shown right here on Hugging Face. You can see that the model will eject EOT underscore ID when it's finished. And that is not actually the end of sequence token that's set in the tokenizer. So if you head over to the files, I always recommend this when you're on a new model. Check out the tokenizer configuration. And if you just search here for stop or EOS, it should take you to the EOS token. And indeed, it's end of text. It doesn't match with the token that's emitted by Llama 3. So you have two options. Either when you're inferencing the model, you have to swap this token to the EOT one, or if you have uploaded this model to your own repo on Hugging Face, you can just manually change this in the tokenizer config file. So let's go back and we're going to quickly load this model here. So I'll head over to the model card and I'm going to just copy some of the code that's ready-made here. Now, I don't usually like using the pipeline approach. It's a wrapper on loading the model, and wrappers make it hard to understand what's happening. So instead, I'm going to load it with model equals auto model from causal. I'll import, I'll say from transformers, import auto model for causal LM. And then I'm going to use that to load the model from pre-trained and the model ID here. This is how we would load it. Now, before that, I need to do some installations. So I'm going to pip install transformers. And I also will want to install a library that allows me to download faster. So pip install HF transfer. I think this is a library that's often overlooked. It's a Rust library, and it allows you to install much faster than you would otherwise. Putting in the -q here is a nice tip too. It'll just suppress a lot of these messages and make it easier to scroll through your notebook. So let's put in the -q when we install HF transfer. And I'll just show you the HF transfer library here. I use this in pretty much all of my scripts. This Rust library allows you to install allows you to download weights really fast. And it requires you to set an environment variable, HF hub enable HF transfer. So we're going to want to set that in our notebook once HF transfer is installed, which it is. So try to set this. I'm not actually sure if this is going to set it. And I don't remember how you set it within a notebook. So go back over to my trusty ChatGPT, start a new chat. How do I set this? And variable Jupyter notebook. So yeah, I think I import OS and then I set it somehow. All right, so there we go. We'll just copy that snippet. And we'll reuse all of these snippets when we're going to run the Grok model. Or why am I saying Grok? I was just listening to an interview with the Grok CEO. I meant the Phi model. So let's paste that in here. And that's imported. And I'll just check there isn't anything else that needs to be installed. If I don't have something installed, it's going to let me know. So auto modeled for causal, and we have the model ID here. And let's see if we can get that to run. So one other tip I have when downloading models is applying the cache directory. So this is where the weights will be downloaded. And if you just set it to an empty string like that, it'll download it into whatever directory you're running the code in. Otherwise, it defaults to the Hugging Face cache. And that can be an issue if you're running on RunPod because it saves the weights to the container and then your container gets filled up, whereas you actually want the weights to be on the volume. So setting cache dir to somewhere on your mounted volume is usually advisable. Now in Collab, it doesn't really matter so much. Okay, so as I think I mentioned last week, these meta repositories, they require you to log in because you had to agree before making that download. So there is one other option here. I could just download it from News Research. So there's an ungated copy of the model available there. And you can see that our download speed is pretty good. Like it's hovering around 100 megabytes a second. It can get up to a gigabyte a second using this Rust library. So always good not to be waiting too long for the model weights. Now, once I have that downloaded, I'm going to download the tokenizer. So the tokenizer script is going to be very similar to the model script. And it's just going to be auto tokenizer. And we do need to import that as well. Transformers import auto tokenizer. Okay. We need to make sure we call that tokenizer. We'll just check here. It's possible I actually might have made the mistake of not starting a GPU runtime, which is a bit unfortunate, but we will have to restart. So I will stop this here. And I'm going to change runtime type. And I'm going to move to a GPU. Let's try move to an A100 and use up some of my credits. I'm connected to an L4. That's the first time I've been connected to an L4. And I'm not sure if an L4 is Ampere architecture. So I really like running on Ampere architecture, which means not a T4, the free one. And the reason for that is it allows you to operate in bfloat 16 as opposed to FP16. So let me just run these and then I'll explain that. So I need to reinstall again, import that, import the model, import the tokenizer. So I'm using Perplexity, which I use quite a bit now, is the L4. Is it L4 or L40? L4 is the L4 GPU Ampere architecture. Okay. Okay. It's based on the Ada Lovelace. Okay, so I think that's ahead of the Turing architecture, which might be all that matters. So let me just say a few things about BrainFloat 16. Today, what are we doing today? We are going to take a look at the tokenizer in Llama 3, and we're going to see how to change the end of the stop token to make sure it doesn't blab on. Then I'm going to load up the Phi model, Phi 3, and we're going to check out the chat template there. So I want to talk a bit about chat templates and how to adjust those chat templates. I'll make a few comments maybe as well on the model that just came out from Snowflake. It's a huge model, 600 billion parameters, but it's a mixture of experts, and it seems to only activate one tiny portion of those parameters. So it activates 17 billion parameters at a time. So that's totally different to Mixtral. Like Mixtral operates, it activates 2 out of 8 experts. So it activates 1/4 of its parameters. And the Databricks model, I think it activates either an 1/8 or a 1/4. But this model from Snowflake activates such a tiny, tiny portion. Now, unfortunately, with 400 billion parameters, it means you're going to have to put an absolute ton of GPUs in order to be able to load it. Using Unsloth. Unsloth is great because it often automates a lot of things like swapping the EOS. So why don't we check if why don't we check out if Unsloth has done that? In the meantime, I've got the model loaded, which is good. So looks like the model is loaded. Let's see how much RAM we took up here. So it looks like, wow, GPU RAM. That means we have not loaded on GPU. So we need to pick change device map equals, and here I usually put in auto, which means that it will be automatically dispatched preferentially to the GPU. And if there's some spillover tokens, it'll put it on CPU. Basically, you never want your parameters to spill onto the CPU because it'll very fast slow down. So yeah, using device map requires accelerate. So we just add in an extra line of code here, pip install accelerate. Accelerate is a library that allows you to manage where the weights go with the idea of accelerating your inference. It also is relevant when you're doing multi-GPU work. You can check out the video on multi-GPU fine-tuning. Accelerate provides a wrapper that allows you to operate with methods like fully sharded data parallel, where you can automatically split a model that's too big to be trained in parallel across many GPUs. So it's quite a nice wrapper that simplifies managing your devices. So we need to install it if we're going to use it, and then we'll be able to load onto the GPU. And in the meantime, we can check out Unsloth. Let's see what they're up to with the Llama 3 model. So we'll put in Llama 3 Unsloth. And the nice thing Unsloth does as well is because a lot of people train the quantized models, they have pushed, Daniel has pushed a 4-bit version up to the hub. So when you start to train a 4-bit model, it actually won't download the full BF16 weights. It'll just download the 4-bit, which means it'll be about 4 times faster for downloading. And let's take a quick look within the files and versions at tokenizer config and see if he has changed the EOS token. So here, no, looks like he hasn't. It's possible though that within the Unsloth code, that end sequence token is being changed. So let's head back here, and we have pip install accelerate. Let's check that that's up and running. That looks good. And now we should be able to run this model. Now, why is it giving me this error? So I'm just going to restart the runtime. And no, I don't want to reset the variables. Model ID, pip install accelerate. I think this should be working okay. I'm going to open up another script just to check if I'm missing anything. And let me pull back my screen here. And let me just pull this so that it's easier to see. Sorry, 1 second. Let's restart the session and check. There's one other thing we can, of course, add, which is flash attention. So I'm going to install that as well. Flash attention will allow you to have improved speed up when you're doing inference and training especially. And that's another flag that we can add when loading the model. So I'm going to add in 2 more things to the model loading here. And I can just split out the arguments so that you can see them a little more easily. That device map is auto. And I'm going to add in this extra parameter here, attention implementation. So this is how we apply flash attention. Flash attention allows, it basically means that the attention matrices are never fully calculated within the VRAM. And instead, they're only calculated deep within the GPU. And that's where everything happens really fast. So you basically never want to be transferring large weights into the GPU and back out again. And the way flash attention gets around that is it breaks up matrices, calculates them fully through multiple steps, and then it takes the answers and pulls them back out of the GPU. And this results in significant speed ups. So looks like we have flash attention installed, and our weights will hopefully persist. And device, we can take that out. We could set the device, but we're just going to take it as flash attention being. We'll take it as turning on flash attention because the GPU should support it. And we're going to set the data type to bfloat16, which should be supported as well. And with that, hopefully our model will load as we want. And we'll be able to run the tokenizer then. So just one note on just one note on bfloat16. So typically models are often trained in 32 bits. Yeah, device and D-type aren't defined. Thanks for that, Loic. No, Hugging Face token is not the issue just because I'm using a model that's not gated. So everything should be in order. So yeah, basically, let me say a few things about float 32. So it's very common to train models with 32 bits. This is a very, very high level of precision, and it allows you to get good accuracy and stability when you're training models. Of course, this means that your model is going to be very large, and so it's common to save your model instead in 16 bits when you're finished training. Now, the common 16-bit type, what it does, well, let's start with the float 32. Float 32, it's going to have a number of bits that are going to represent the number. So you can think of it as the leading digits in a long number. So you could have a number that's like 8 point something like this. And then it's going to be multiplied by 10 to the power of some other value, which could be something like this. So if you have this long number represented in 32 bits, you basically use some of the bits to represent this part here, and you use some of the bits to represent the exponent. And this is true pretty much for any number you represent in binary. If you've got lower number of bits to represent, well, you're just going to have less precision here, and you're going to have less precision or less range in what you're able to cover in the exponents. And so when you move from 32 to 16 bits, that's basically what you do. You start cutting down on the precision here, and you start cutting down on the range that you have on the 10 to the power of, let's say, 5,000 here, or let's say 50,000. You basically lose precision, and that's what happens if you go to FP16. But the idea with BF16 is instead of compromising on your bits for the exponent here, you keep those the same, and you just compromise a lot on the bits that you have for the number up front. And this ends up being a good trade-off because it's actually important to keep a full range of your numbers when you're training models. And so it's better and more stable if you can go to brain float 16, which keeps pretty much the same accuracy in the exponent as 32 bits, but it compromises a lot more on the front bits. Now, it's not as bad as 8.6. There's still numbers here. That's the idea of brain float 16. It's not supported on the T4 GPU, but it's supported on most other GPUs. So now we've got the model loaded and we've got the tokenizer loaded. And the next thing I want to take a look at is the tokenizer chat template. So let's just print out the tokenizer and take a look at what's in it. So there's actually a lot of added tokens within the Llama model. It's got basically a ton of reserve tokens that I don't really see what they're used for, if anything. So I'm not entirely clear why they have so many added tokens on top of what are much more common, which are the beginning of text and the end of text tokens. Now you'll see within these special tokens, there's the EOT_ID, and this is the token that's actually being emitted when the sequence is finished. And this is really what we would want the end of sequence token to be when we're going to run inference. So let's take a look at how a chat template works by applying it to a prompt. And the prompt we're going to set is tell me what the planets are in the solar system. And what we're going to do now is try and format it so that it's ready to be tokenized. So we want to apply the chat template. So we're going to do we're going to do tokenizer, apply chat template. And we're going to apply that to the prompt. And we don't want to tokenize it. So we're going to have to say tokenize false. So it's here, should allow us to tokenize. And before you tokenize, you actually have to put this into messages format. So it's not enough to just pass a prompt into a chat template. The chat template expects messages that have a user or an assistant role. So what I'm going to do is take this prompt here, put it into ChatGPT and say, give me some code. Put this prompt as a message with a role of user in an array of messages. It's like the chat ML format. So let's see, hopefully it'll follow Python. This is what we want. Now, actually, we wanted to say content instead of text. That's the format. And yeah, we don't actually want the assistant message. So that's fine. I'll just copy that out and manually adjust it as I need to. So we can start off with an empty array of messages, and then we can just append there, print the messages, and then we can apply the messages, apply the chat template to the messages like this here. Just want to put in a line to make it easier to read what's happening here. Right, so here we have an array of messages. We've got a first message, tell me what the planets are in the solar system, and the role is user. And then we've applied the template. And this is what the template looks like for Llama 3. It's very different than the template that was there for Llama 2, which used inst and end inst to start and end the instruction. The way that the Llama 3 template works is it wraps, first of all, the role like this, user, and then it gives the assistant message here. And you can see that right at the end of the assistant message, it puts in this end of token here. So yeah, we have a question here from Ian, pre-prompt, this is a conversation. Let me put that up on the screen. I see. So you had to use that approach there. Nice. Okay, nice. Yeah, always good to have a few useful prompts. So I'm going to add in just an assistant message so we can see how that looks if we change this to assistant. And here I'm just going to manually put in a prompt. say there are 8 planets. And now when I tokenize it, you'll see I have the user message. The user role rather is wrapped in the headers. Then we have the user message followed by EOT. And then we have the start header. And then after that, we have the assistant message, which is also finished off by end of text. So with that, we can move to generating. So we'll need just a small piece of script in order to generate some answers. I'm going to take out that assistant message just so that we have the prompt on its own. And we'll generate here a snippet of code for generating. And what we're going to do is generate some outputs, and then we're going to decode them. And we're going to generate some inputs, and the inputs, we're going to tokenize them. So tokenizer encode messages. So we're going to take the messages that we've applied here. So I'm going to set this equal to formatted messages. Print formatted messages. So here I'm just applying the chat template so that we have the messages here in a nice format. And then we're going to take those formatted messages and we're going to pass them in as an argument for the inputs. And just so we can see everything that's happening here, we'll print out the inputs. And so when we tokenize this string here, we're going to get a series of tokens, which you can see right here. And the very last token is this end of text token here. And the very first token in this sequence is token 128,000. So actually Llama 3 has a vocabulary of just over 128,000 tokens. That's quite a few tokens. It's about 4 times what Llama 2 has. If you allow for more tokens in your vocabulary, it means that for a given sentence, you will generally need less tokens. So it results in needing less tokens to generate something of the same length. Also, more vocabulary allows you a bit more flexibility than in covering different languages or outcomes like that. So we've got the inputs printed here. And next, we want to take those inputs and put them through the model. So model.generate. And I need to set up my input IDs here. So I need to get a code snippet to help me out. So let me find that here. So I'm just going to go to Hugging Face Documents, model.generate. We'll find a snippet that we can add in. So here we have text generation strategies. And we can scroll down here. So we have the inputs and the tokenizer. So that's exactly what we have. And usually we'll add in return tensors, just so we have tensors we can pass in to model.generate. So now this is in tensor format. So you can see instead of it just being a straight list, we now have it as tensors. And then we can pass in outputs equals model.generate for the inputs. And we can additionally specify some flags for generating. So I think my pasting here just need inputs like this. Got the outputs. Outputs equals model.generate. You can see here we've got a pasting error. So let's actually import a generation configuration so we can adjust that. So I'll just copy exactly what they have here. I'm going to split this onto new lines so we can see what we're doing. and pasting in the generation configuration here. We'll copy this, and I do need to copy quite a few things, so I'll copy and then delete. So I've already, of course, loaded the model. This is loaded. Don't need early stopping. And I do want to set this end of sequence token. I'm going to set it to the end of sequence token just so you can see the model blabbing on. And let's see if we can set temperature equals 0.1. Outputs. And then we want to print outputs like this. So we do have a bug here. So let's take a look at how we can debug this. The inputs. We have model.generate. We have inputs equals tokenizer. So we have the inputs, and we're passing the inputs into model.generate here. So we can just try to use tokenize. All right. So let's just check that everything here is correct with the help of our friend from ChatGPT. So I'll put in here what I've done on the chat, put in the inputs, and next pass through the generation instructions here. So I do need to fix a few things in this to get it working. So here we go, my tried and trusty. So we want to copy from here. We've got the inputs. This here, of course, is doing something different, so we don't want to copy that. And yeah, I think here, this is probably my error that I need to pass in my input IDs like this. And input IDs, inputs. And let's just pass this in here. And we'll just remove that from now. Default to default generation configuration. And we do need to pass the input IDs to CUDA. Pass them to CUDA like this. So they're now going to go onto the GPU, hopefully. And here, finally, we have the outputs. And with those outputs, we can output equals tokenizer decode and outputs. So go back and check my rubric here. So I can just print these like this. So here we have, tell me what planets are in the solar system. And we've got the model generating the outputs. and we've passed in the user message, and yeah, I need to pay more attention to this here. Folks, I'm going to move on from this here because I don't think I need to have this prepared in advance if I'm going to be able to demo it properly. My hope was to be able to show you a little on the chat template, which I have done, but I'm struggling to just come up with the correct syntax for generating some outputs. So I think the best thing I can do is probably to move on and to talk a little bit about the phi model. As I mentioned, the important thing is to set the stop token. So you have two options for that. I'll just show you something I did on the function calling model. So you'll see if you go to the Llama 3 instruct and you go to function calling by Trelis, which is a public model. So we have meta Llama 3 instruct and go to function calling. You can try out this model if you like a little bit later on. And if you check the files and versions here, you'll see that right under the tokenizer configuration, I've just manually changed the stop token. So if you follow on down to here and check the EOS token, you'll see that it's EOT_ID. And that will allow you to stop generation automatically. And that will save the model from blabbing on. So that's one way that you can change the generation so that it stops for you. And the other approach, which we should have just taken a look at in the first place, to be honest. If I go back to this repo here and copy, this is still my function calling repo, which you can take a look at. But if we go back to the Meta Llama repo here, we can just copy the script that we have from here and set up a pipeline. So if I just open a new code cell, paste in here, swap this to News Research so that we don't get blocked. And I need to just restart the session. So here we'll do text generation. It's being loaded automatically onto the GPU in bfloat 16. We're going to ask what are the planets in our solar system. And we'll apply the chat template as I talked about. We're going to add a generation prompt. That is important, and that probably was missing when I was going through the example. That is going to just add on a little piece of the assistance response to prompt the model to continue. It's yeah, it actually is missing here. So after the prompt, there should be an extra piece that looks like this. I can just show a quick, the tokenizer needs to be loaded, of course. So if I just quickly load the tokenizer like that. And if I just show now what that looks like. So I need to set my model ID. Let's comment this out because I'm going to load it differently. So here, if I load the tokenizer, I just wanted to show here what it looks like if I apply the chat template. So it's applying the chat template, adding the generation prompt. And yeah, you can see that automatically it's put in a terminator. So not only is it going to stop if the EOS token, which is not the finishing token, is generated, but it will also stop if tokens with this ID here are generated. So now when we run this cell here with the prompt, and I'll just delete this because we're finished with it. What it should do is load the model first. It's downloading the shards here. I wonder if I can accelerate that by just putting in the cache directory instead. So I'll just put in cache here. Load the model. Oh, it's still going to download here, it looks like. I'm not sure how you set the cache directory when using the pipeline. But in any case, this is going to allow us to stop the model from generating. So what I want to do next is just take a quick look at the phi model from Google, rather from Microsoft. So I'll put in Microsoft phi. Take a quick look at this. the instruct version. Cache tier, yeah, it basically tells you where to put the weights when they're being downloaded, and you want them to be downloaded to the volume you're working on. If you're on RunPod, you want them to be downloaded to the volume, not to the container, because then you'll run out of space quickly. So it allows you to control where the weights go. And if you keep using that same directory, then you won't need to really download them, at least during the run you're on. So here's the Phi 3 mini model. I believe there's a larger one, 14 billion in size. And this model here, it looks like it's about 5 plus 3 gigabytes in size. So about 8 gigabytes of probably about 4 billion parameters in total. And we can take a look at the tokenizer configuration. So here looks like a lot of added tokens too. You can see the stop token is the end of text token here. So we'll see whether that ends up actually stopping generation. And the chat template is this one here. We'll take a closer look at that. So what we'll do is just copy the name of this model like this so that we can bring it over. And in a moment, we'll give it a run here in adjacent to the Meta Llama model. So right now it looks like the model has loaded. That's Llama 3 7B. And we're just waiting for a response to our question, which is what are the planets in the solar system? And I also would be interested in seeing what the prompt looks like. So I'm going to just print that afterwards. So yeah, as you can see, the model is, wow, yeah. All right then, matey. Yeah, I don't know why it's answering like a pirate, but seems like that's what we're getting from the Llama 3 model. Oh, well, that's because we told it you're a pirate chatbot. So yeah, I suppose that explains why. So we've set up the pipeline, and if we can just move this here, we should be able to just do another prompt without forcing the model to reload. So we have the prompt, the messages. Let's move that to a new cell. We'll rerun it again without pirate mode. We'll see if it'll be less verbose. What I want to test is that it's actually going to stop generating because we've defined that end of sequence, that end token. So here, yeah, it's giving me quite a long response. Let's just ask a simple question like, what is 1 plus 1? See if it responds to that. Yeah, okay. So it does give us the answer there, which is what we like to see. Now, let's just take out this EOT and see what happens by contrast. So what I was expect, oh, unfortunately, my runtime looks to have gone down. And that's possibly because I'm not actually sure why the runtime has gone down. But I think we'll move on here and take a quick look at the Phi 3 model. So we have Phi 3 ready. Yeah, the inference here is very slow. If you use TGI or VLLM, how does it become so fast? So one thing that really helps is that they use CUDA graphs. So there are specific graphs that are set up in advance when the model is being loaded. And those graphs, you can think of it as a way of optimizing the token flow through the model. So that really helps. I think it helps by a factor of 3 or 4. And that's all wrapped in when you're running on TGI. If you're running here, we could technically use Torch Compile. And if you do Torch Compile, you're able to get a lot faster inference within even a notebook like this. So yeah, generally it's like I pretty much only use TGI or VLLM if I'm going to do any inference. So let's just see quickly if we're able to get a response here. I have installed everything. It shouldn't need to download the model again. And when we did a short question, it was a bit faster, but it's going to do a long answer now because I haven't put in the end token. And that's on purpose just to show the effect. So yeah, here's a long response. And yeah, you can see it's not actually stopping. And the reason why you don't see the end token is because I've suppressed, well, the token has been suppressed here by the pipeline. The pipeline is a wrapper and it's got things under the hood that you can't see, which is why I usually do the generation, although I was stumbling a lot with that today. But normally when I'm generating, what you can do is you can get it to show every single token, even the special tokens. And when you do that, you'd see that end of sequence token is probably actually somewhere here. But it's just, it's not being shown. And then the model is blabbing on. So yeah, this is how you fix it, by putting in the correct end of sequence token. So with that, let's take a quick look at the phi model. So we load it here. And I'm going to leave commented out the Meta 3 model. And this should take a second. Now, we could actually pass in here trust remote code equals true. I'll show you what that is doing. I'll just click stop and I'll run it again. So what trust remote code does is allows you to run code that's in the repo itself. So if you go into the Phi3 repo, you'll be able to check out what's within it. And you can see here the tokenizer, the model, but you'll also see these py files. So modeling _ Phi3. And yeah, here's another one here that's setting up the configuration. And if you want to be able to load certain models that are not standard models integrated into transformers, you need some script that tells you how to load the different modules. And that's what these scripts do. So if you look at modeling phi, it's going to be a description of the model itself. And these are going to be called for instantiating the model. Now, once the models get built into transformers kind of natively, then there's no need for these anymore. And so you don't need to have the scripts in the repo. But when you do have scripts in the repo, you need to run trust remote code, because you need to run the scripts and you're saying basically, okay, I trust those scripts. So that's what this is. All right, so it looks like some of my parameters were offloaded to CPU. I have a few things that I need to do here. I need to first of all delete to make some space. I may just run out of space here, but let's see how far we can get. What I'm going to do is restart, because that should allow me to now. Let's see, if I run inference now, I know that I have some of my parameters on the Meta device, which is not ideal at all. Yeah, thanks. Trust remote code explanation was good. Well, let's see if we can just run on the Meta device anyway. But I suspect that may not work. So I'm just going to reload here. And we'll try reload the phi model. So here comes the phi model. Okay, that's actually fine. I do have a bit of space. So we'll load this model like this. Okay, it's still on the meta, so I need to restart the runtime, restart the session. The variables will be lost. That's okay though. Now we'll load the model. And then we'll pass through the messages. Okay, loading the shards. It's pretty quick. Loading the messages here. And so it has no attribute apply chat template. And that may well be because we can just follow maybe a script from the phi repository instead. Maybe they'll use auto model for causal, which I would like to see. No, they're using a pipeline as well. So yeah, the problem is I didn't load my tokenizer. So I'll do that. To load the tokenizer, I need to load it from transformers. So from transformers, auto tokenizer. Then we should be in good shape. Except that it doesn't seem to recognize the apply chat template. So I think what I'm going to do here instead is follow the instructions, which is often a good idea. Now I have the prompt defined. Pipeline messages. And the model needs to be defined, which it appears it hasn't been. Yeah, so actually here's the loading. This will be good because we'll be able to better control how this is being loaded. So let's load it like this. Model ID can be put in here. This is what I was trying to do earlier, but somehow I wasn't being very successful with it. And this just needs to be imported. Formers. So the checkpoints are loaded. Now my tokenizer is loaded. And now my messages are going to be loaded. So I have, yeah, this is the sample inference code, the messages, the pipeline, and here, let's just copy everything here from the examples. And we do have an issue. Yeah, why are the checkpoint shards loading each time if the model shards? Well, yeah, basically when we've downloaded the model is just sitting on our storage. It's not on the GPU. So when we call the model to load it, the model is being moved from our hard drive up to the GPU's VRAM. So every time you do that, you're going to see each shard being loaded one by one at a time. Now, I think my issue here is that I'm not importing the pipeline correctly. So that should be now in business. And it looks like we are inferencing. Okay, so here we're asking some different questions. We'll just ask a simple question now of what is 1 + 1? See what that comes up with. One thing I want to show is what that chat template looks like. So yeah, 1 + 1 = 2. It's a basic arithmetic operation. And it does look like it's printing out and stopping. So there's no issue. The stop token seems to be the end of sequence token in the case of phi. So there isn't that same issue as with Llama. Now, just for interest, if we print out the tokenizer did earlier, see here that it's using a Llama tokenizer with all of these added tokens. And we can probably just print tokenizer chat template if we want to look at the chat template, which is formatted in Jinja format. So you'll always save it in a .jinja file if you need to apply a custom template. You could change that template by setting tokenizer chat template equal to something new. So that's how you would change it. For example, you would say tokenizer chat template, then you would just do equals. Then it's common to wrap it. You need to be careful. Everything is on the same line for properly formatted. So yeah, this is an example of how you could set it if you wanted. But when you apply that chat template to a series of messages, so let's just say formatted template, rather formatted prompt equals tokenizer apply chat template, and we'll apply it to the messages, and we will say, do we want to return the tokens? So I'm just checking here, tokenize equals false and add generation prompt equals true. So we want to add that here. Yep, the chat template is tied to how it's instruction tuned. So it's set during the instruction tuning, and that's how you give the model the instruction tuning, is by using a specific template. And apply chat template is kind of a way to make that easier. So here I've got the formatted prompt. I've just applied the template, and then if I print that formatted prompt, I'll be able to see how it performs just like this. So you can see the system message and then the user message here, and then assistant. So actually Phi is not following Llama 2 or Llama 3 in terms of performance. It's following its own performance, which is a bit of a chat ML type syntax. You'll see it has a beginning of sequence token here. And yeah, basically for the user, it will start by saying user and then give the user message. And then it will say end like this here. And then the assistant message. Now, just one small thing I'll show you, which is the difference between putting add generation prompt true or false. If you put that equal to false, it's not going to add on any extra piece that prompts the language model to say something. But interestingly, within this chat template, there is no feature here that is affected by saying add generation prompt true or false. So it's not actually, it's not going to make a difference whether or not you set add generation prompt to true or false for this specific chat template. There are some chat templates where it will make a difference. I think in the case of, let's see, I'm not sure if like the Mistral model will make a difference. I don't think it will. I'm trying to think of an example where it does make a difference. Maybe in the Google Llama model, I don't remember. Let's check that out. Actually, we can see if we find an example. Llama 7B. Now, there's no point in looking at 7B because, as someone just said, base models do not usually have chat templates, so we're not going to find anything of interest there. But here under tokenizer configuration, we'll see the chat template, and right at the end of the chat template, yeah, if add generation prompt is this, it will add an extra little piece. So I know I'm just going to wrap up now very soon, but just as a little demo of manually changing the prompt, let's just put in a new line of code and say tokenizer chat template and set it equal to this chat template here. And I do need to wrap that. So let's see if I can find a way to rewrap it. Okay, there we go. And now let's apply this chat template. It doesn't support the system role, which is fine. It means we'll just take this out. Let's consider a series of messages that are just like this. So we've just considered a user message, apply that chat template, and print out the formatted prompt. So here with Gemini is what you would get. You get start of turn user, what is 1 + 1, end of turn. And here's the difference if you put in add generation prompt of true. You've got this additional piece here, start of turn, that will prompt the model to start chatting. So basically, you have to be careful with chat templates if they have an add generation prompt, because if they do, you need to make sure that's being added in when you're fine tuning or training. It's also needed if you're going to be running inference, because if you just leave this piece out, the model won't naturally progress from this point after end of turn as it would with start of model here. So folks, that's it for this week. I'm going to try going forward to stay on time with a 1 hour slot on a Thursday. I think it's helpful for people if it's consistent and you know that it's that amount of time commitment, and you also know when you can call in. I think for this one here, I have learned I just need to be better prepared with some scripts so I can move through the topics a lot faster. I ran into a few issues today that slowed us down, but such is life. It just shows you that when I make the real videos, it takes me a lot of iterations before I manage to get content out there that's working. So appreciate everybody watching, and you can find out more info on trelis.com, or right back at the top of the chat, you can find a link to the Google Collab notebook. All right, folks, I'll talk to you all soon. Cheers.